So what exactly is soil saturation? Soil saturation occurs when water fills all pore spaces in a given area, displacing air. This reduces the shear strength of the soil and makes the soil behave like liquid when exposed to stress, such as an earthquake. This condition normally follows excessive precipitation, flooding, or in zones characterized by a high groundwater table.
Saturated soils affect key geotechnical structures like retaining walls, embankment, and foundations. For retaining walls, water increases lateral pressure, which can lead to failure if there's no proper drainage. Next, embankment, used in roads and railways, may collapse or settle when the soil underneath is saturated. That's why drainage and reinforcement are important. For foundations, saturated soils reduces bearing capacity and increases settlement risk. In such cases, deep foundations like piles are used to reach stronger soil layers. Overall, saturated conditions require careful design and good drainage to ensure the structures remain safe and stable.
In December 2008, a landslide in Ampang, Malaysia destroyed 14 homes after heavy rainfall saturated the area. This event, known locally as the Ampang Hill of Death.
First, loss of effective stress due to high saturation. When soil is saturated, water fills the spaces between particles, reducing the contact between them. This weakens the soil and makes it less able to support loads. Second, slope instability and mass movement. Saturated slopes are more likely to fail because the added water increases pore pressure and reduces the soil's shear strength, making landslide happen. Third, surface water accumulation without proper drainage path. If there's no proper drainage systems, water builds up on the surface, leading to erosion and weakening of the soil structure. And lastly, poor understanding of subsurface water movement. Without accurate knowledge of how groundwater moves underground, it becomes difficult to design safe and stable structure, especially in areas with high rainfall.
It's important to plan and anticipate soil saturation in any proper use of land. So engineers have encountered these problems before and have devised methods to solve them.
Now we're going to talk about the lab test that involves in the saturation of soil. Okay, the first test that we're going to talk about is the constant head permeability test. Okay, this test is to measure how easily water flows through the saturated soil, and water fills all the voids, so flow is measured under the full saturation, and also important for analyzing the seepage, drainage, and also slope stability. And then the second test will be the consolidation test. The consolidation test is to determine how much saturated soil compressed settles under a load over time. And also, when load is applied, pore water is squeezed out, and also soil particles move closer. Important for predicting a long-term settlement for clay soil. Lastly, the triaxial test. The triaxial test is to measure the shear strength of the saturated soil under the different loading and drainage conditions, and also to use to study how pore pressure and affects the effective stress and strength. Lastly, the essential for slope stability, foundation, and earthwork design. Thank you.